Alright, ladies and gentlemen, here we go. Here is your exam prep for your fall final 2014 physical science. As we go through, for each unit, we'll start out with the vocabulary terms. So my advice to you would be to go through, and if you can find definitions in textbooks or online for this, great. If you can find them in your notebook, probably even better, because then you're looking at, what I wanted you to know. So if you can make this make sense to you, you are allowed to write down any and all vocabulary terms along with their definitions. On the exam, it will show up as a multiple choice question, so you will also have a word bank built in of your 4 choices. So here's Unit 1. Remember Unit 1, we talked a lot about some of the basic things having to do with science and scientific method. So if you need to pause this to be able to write these all down, go ahead. I'm going to move on to the next slide. Here are some things that you need to be able to do. I need you to be able to convert units using dimensional analysis. And that would be where we had to set up those little conversion factors, the fractions, where you had to have one thing on top and one thing on bottom in order to be able to convert. You can also use the method of moving the decimal for certain metric conversions, just going back and forth from the left to the right, depending on whether you're multiplying by 10, dividing by 10, multiplying by 100, something like that, like from centimeters to meters. That would be when we'd use that stair-step method that we talked about. Graphs, make sure you can make a graph, make sure you remember all the different things that go into making a graph, plotting it, all that good stuff. There will be one problem on the exam that's not multiple choice, where you actually have to make a graph and then maybe even be able to interpret a little bit of the data on a graph. So if I give you a graph and ask you some questions about it, you can look at that and say, oh yeah, okay, here's what's going on. At this point, the temperature was 12 degrees Celsius and something like that. So if you need to pause and write some things down with this, go ahead. Measurement, make sure you can measure accurately using any and all of measuring tools. Make sure you remember that things like significant figures, adding that one extra number that you can estimate. We did talk about density. Make sure you can make density calculations, explain the relationship between mass and volume. We did the earthworm lab, if you remember, when we went through and did some things with density and mass and volume. So make sure you understand that relationship, and that density is constant no matter how much of the substance you have, because it's that ratio of mass to volume. So this would be a good equation to include. If you have like a section on your help sheet that's just equations, you can have the density equation. Right, Unit 2. We did a lot of stuff in Unit 2. Unit 2 was like the majority of the semester. Here's all of the vocabulary terms that you want to make sure that you have. Once again, same thing. You can write any and all of these. You can look up book definitions. You can use definitions that you had from earlier. You can write your own, whatever you need to do. Make sure with the Newton's laws there are 3 of them. Right? Make sure you include all 3 of those in your definitions for vocabulary. Equation. This is where there was a lot of stuff in Unit 2 in terms of equations. So we have speed, velocity, acceleration. We have force. We have momentum. We have weight. Reminder that G, when you're talking about the weight equation, is that 9.8 meters per second per second. We also, in this unit, talked a lot about those graphs, position versus time and velocity versus time, and the difference between them. We did a lot of stuff with this. All right, so you can expect some questions on that on the exam, maybe even one where I ask you to sketch out a graph based on some described motion. So if you remember the moving man activity, we did that. Also, if you can remember the roller coaster demonstration that Mr. Wood did with you guys when we went through and talked about that stuff as well. So know the difference between those 2 graphs and what the different types of lines mean on each one. We did like a 3-column thing on that to kind of summarize that up, and so hopefully that you can maybe include that on your help sheet. That might be helpful. Also, with any of the equations, if you need all versions of those, like if you need to change this to solve for distance, or change this to solve for position, or change this to solve for time, any and all versions of that, so you don't have to worry about doing the algebra on the exam, might be helpful for you as well. Here's some other things I need you to be able to do. Draw and label forces acting on an object, things like friction and normal force and applied force, and using the arrows to be able to do that. Be able to just describe an object's motion based on the information in a force diagram. So if you see the forces are balanced, you can remember that's either stopped or moving at a constant speed. If they're not balanced, it's going to be accelerating. Explain the difference between mass and weight. Mass being just how much stuff there is, and weight being that force of gravity. Okay, Unit 3, energy. I forgot to take this out on the title. We didn't talk about work and power, so don't worry about that, but here's your vocabulary. We did end up adding heat, temperature, conductor, and insulator. Here's the equations that we used, and this is the stuff for potential and kinetic energy, and we did do some calculations with this. So again, if you want to make sure that you know how to rearrange these and that you write the equation that we need to be able to solve for velocity here, which involved that square root, that would be a good one. And then any and all versions of these equations that you need to be able to solve for height or mass or velocity. Usually height for this one and velocity for this one are the two more common ones that you might need. Some things you need to be able to do. Remember the energy skate park thing, being able to explain how it's conserved. It starts at the top with a certain amount, ends up with the same amount at the bottom. It's just been converted into a different type. As long as we ignore friction, mechanical energy is conserved, and that kind of goes along with that whole energy skate park thing again. With heat and temperature, be able to explain how they're related but different, how heat is the what gets energy from one place to the next, and then temperature is measuring the movement of the particles, and talk about how if I add heat to something, the temperature is going to change, but it's not the only factor that determines how much the temperature change. Remember that little lab we did with the washers, where the water changed a bunch, but the washers only changed a little bit. And then waves and sound. Basically, with waves and sound, it's all of these definitions, and then some of the concepts that we talked about, like resonance and harmonics. Be able to talk about, you know, all the relationship between wavelength and frequency. So, I mean, this was very heavy with vocabulary terms, so you may want to go back to your wave poster and take some of the stuff off your wave poster to be able to explain what's going on with some of these things, especially with the transverse and longitudinal wave. Hey, there's the start of our early morning here. With those two types of waves and being able to label all the different parts. So this is a great start. These are all things that you can include on your help sheet, all the vocab terms, all the equations, and then anything else that we talked about in this. And this is a great place to start, and then you can see if that helps you at the practice exam, which I'll be giving you in class. So good luck. If you need anything, as always, please don't be afraid to ask, and great semester. Good job, everybody.